This video corresponds with Lesson 3 in Unit 4A, dealing with the sum and difference of cubic expressions. So we are going to take a look at these two different factoring patterns, the sum of cubes and difference of cubes, talk about how we get the values to create the factors that we need in order to factor these expressions apart. Let's first start with the sum of cubes. So, sum of cubes means we have two terms that are being added that are both perfect cubes, as you can see here by a cubed plus b cubed. In order to figure out a and b for this gigantic factoring pattern, we need to find the cubed root of the two different terms that we have. So, we're going to assume this is in AB order, alphabetically. So, if it helps, off to the side here, we can go ahead and write these two terms down, so that way we can just look at the formula and plug everything in as you see it. So, x cubed, to find that a value, all we're going to do is take the cubed root of x cubed, which is just x. Then we're going to look at 64. You can take the cubed root of that, it comes out to 4. So in order for this pattern to work, they both have to be perfect cubes. That's the case here. All we're going to do is go look at our two factors here and plug in the values as necessary. So the first factor is a plus b, so we plug in x plus 4. The second factor is a squared minus ab plus b squared. So a squared, I'm going to have x squared, minus ab, which is x times 4, plus b squared, which would be 4 squared. So for right now, I'm just going to plug in the numbers where they're supposed to go, and variables as well. Plug in all the terms as needed. Then go ahead and simplify, rewrite whatever you need to rewrite to make it look as simplified and as standard form as possible. So, the x plus 4 is not going to change. In the trinomial, we can simplify that a little bit and make it look cleaner. So the x squared is going to stay x squared. Instead of saying minus x times 4, let's call it minus 4x. Plus 4 squared, we can call it 16. And just like that, we've gone ahead and factored that cubic expression using the sum of cubes. Now, that's about as easy as it gets because it only has one variable term. The variable term doesn't have a coefficient with it. We have a constant term, so there's less to work with here. There's not as many pieces to it. In the second example, you'll notice there's a little bit more to it. We have two variable terms, both cubes. We also have them both having coefficients. So there's going to be more pieces to this that we're going to have to be really careful with when we go ahead and substitute it into our factoring pattern. Now, we're going to do the same thing by identifying what's our a, what's our b. So the a is going to come from the 216x cubed. Take the cube root of each. So the cube root of 216 is 6. Cube root of x cubed is x. Now do the same with 343y cubed. The cube root of 343 is 7. Cube root of y cubed is y. So our a term is going to be 6x. Our b term is going to be 7y. We're going to go ahead and plug it into our format. Now, for the first part, it's just a plus b. So 6x plus 7y, that's not too bad. For the trinomial part, so when we plug into the second part of our factored expression here, we need to be really careful that when we substitute, since we have not just a singular variable or a singular constant to substitute in, we have terms that have a coefficient with a variable. We need to make sure that those terms are substituted in correctly. So what I'm going to do, so a squared would be 6x squared. I'm going to put the 6x in parentheses and put the squared after it, because that squared needs to affect both the 6 and the x. If you forget the parentheses, you're probably not going to remember that the 6 also has to be squared, and it's just going to affect the x. That is not correct. So when you substitute in a problem like this, when you have a 6x or a 7y, make sure you put parentheses around it, especially if there's an exponent affecting it. Minus ab, so 6x and 7y, plus b squared. So by b was 7y, once again, we're going to put that in parentheses, so that way I realize my squared, the power of 2, has to affect both the 7 and the y. So now we're going to go ahead and simplify this. So the first factor, the binomial 6x plus 7y, that stays put. Now we're going to go ahead and simplify the trinomial. So 6x squared, we square both pieces. So 6x squared turns into 36x squared. In the middle, 6x times 7y, we multiply the 6 and the 7 to get 42. X and y, we just tack them on. Plus 7y squared, we square both parts. So that turns into 49y squared. And we have ourselves a factored expression using sum of cubes. The second version of this is when we have the difference of cubes. It's pretty much the same idea, and you're going to notice the factoring pattern is really, really similar. The difference is you'll notice the plus and the minus signs kind of shifts and trade spaces between the sum pattern and the difference pattern. It's the same idea though. If I have a difference of two cubic terms, you'll see a minus sign. Both terms will be perfect cubes. We're going to do the same thing that we did up above. So we're going to still figure out what the A term would be, the B term would be. Then it's just a matter of plugging it into our pattern and recognizing that the signs kind of trade spots. So if we look at x cubed minus 125, we're going to go ahead, the A term again, take x cubed, find the cubed root. A is going to be x. For B, take the cubed root of 125. B is going to be 5. So now all I'm going to do is take those terms, plug everything into our format. So now we have A minus B, so it's going to be x minus 5. Now we'll go ahead and plug into the trinomial. So A squared is just going to be x squared, plus AB, so it'll be plus x times 5, plus B squared, which would just be 5 squared. Binomial is going to stay the same. Trinomial we're going to rewrite a little bit more nicely. Call it x squared plus 5x plus 25. And there we have factored out our difference of cubes. Now, in this last example, we have 16x cubed minus 2. So it's definitely a difference. But if you look at face value, it doesn't look like this factors using difference of cubes because you can't take the cube root of 16, nor can you take the cube root of 2. However, as you learned back in the first lesson, we always should technically check for a GCF if we can get things to factor. So this doesn't mean difference of cubes right now. However, if you look at both of these terms, you can take out a GCF. If I take a 2 out of both terms, I'm going to have 8x cubed minus 1. If I look at what's left in parentheses, that is a difference of cubes pattern. Okay? The 8x cubed, that'll cube root. 1 will cube root. Now I can use that pattern and break it down using the factoring pattern we see up above. So I'm going to focus on the 8x cubed minus 1 to get my A and my B value. So 8x cubed is going to be my A. Okay, we're going to cube root that. We'll get 2x. Cube root of 1 is going to be 1. That'll be my B value. So as I carry through this, no different than the other factoring problems. If you have a GCF that came out front at first, we're going to just bring the 2 down, and then we're going to start and plug in these values into our pattern. So my first factor is A minus B. So in this case, it's 2x minus 1. Then we have A squared. So we have 2x squared plus AB. So 2x times 1 plus B squared. So that would be 1 squared. Now you notice I put the 2x in parentheses for that A squared because both the 2 and the x must get squared. I didn't worry about it really so much for the B term when I did B squared because it's just one singular piece there. It's just the 1, nothing else is with it, so we don't have to worry too much about it. So my final answer is going to be this. I drag down the 2, I drag down the 2x minus 1. Now I simplify what's in the trinomial. So 2x squared turns into 4x squared. In the middle, 2x times 1 is just 2x. 1 squared is 1. And now I have myself a fully factored expression that had a GCF and also had the difference of cubes pattern. So with these, kind of in a way similar to difference of squares, you learned about that pattern in the first lesson. However, with cubic expressions, if we have 2 terms, both that are perfect cubes, it doesn't matter if they're being added or subtracted. They are able to be factored apart, but they have to follow these specific patterns. That is how you factor apart cubic expressions, whether you're dealing with the sum or the difference of those cubic terms.